Just attended a presentation about Mach 7 physics. Professor from the University of Illinois at Urbana-Champaign, and he leads the advanced propulsion laboratory lab there. And I thought it's an interesting case study of how applied science actually can work, and also how applied science can fuel machine learning models that can then create this data avalanche that hopefully will one day allow us to design really complex systems in virtual space, and then apply it to the real world after very precise simulation. So the lab is working on diagnostics for hypersonic air breathing engines. So the problem here is that you're letting in air at high speeds that gets compressed and then combusted, and then creates a thrust in the back in the nozzle that then creates the speed. So the problem here is that you are sucking in air at very high speeds, and therefore and then combusting it while it's being sucked in. So there's a very ideally a constant flow of high-speed air that's being compressed through the inlet and the speed. So you're using the speed as a pressure cooker, if you will, and then you're using the fuel to burn the air. So you're using the oxygen in the air as fuel together, of course, with, you have fuel, but then you're using the oxygen to burn the fuel. So the problem here is to do all of this in a very stable manner. And that's what Professor Lee, the leading PI in the lab, is working on. So you want to make sure that this combustion happens in a stable manner. It doesn't, explode or not burn and then burn. And like, you want to have a stable, fast, repeatable, predictable combustion cycle here. So that's the main problem. And he's using laser diagnostics to understand designs of engines, designs of fuels, chemistry designs, and material designs. So all of these elements have to be tested before they get implemented in the real world. And at very high speeds, of course, you can't, there's a chicken and egg problem here, that in order to get to those types of high speeds, you have to have proper designs in place before you even get to those speeds. So even if you wanted to test a la SpaceX in real settings, even to get there is a problem. So in other words, you want to be able to improve your simulation techniques, and Lee is actually working on that in the lab. So he's feeding some of his ground truth data that he gets through laser diagnostics back into the machine learning models, and I think that's very interesting. I just wanted to mention this as a good example of how physics, engineering, and machine learning are converging, and this idea that we could get to a point of having in virtu design of complex systems. This is a nice case study of how this actually could happen. And it also feeds back into some of the more broader themes that occupy us, such as, for example, space travel, or generally hypersonic travel is something that could be achieved in maybe a shorter period of time than we think. And I think it's also a good example of how we can actually use advances in deep learning and AI to maybe get faster results in designing complex systems, such as, for example, supersonic propulsion. Thank you.